And so actually, Rob Mee's comments this morning when FaZe asked him, how does data fit into this mission that Pivotal has to transform how the world builds software? Rob called out a few things that really hit it on the head in terms of just basic questions about how are we using data to make better applications? How are we building smarter applications? And then finally, how are we making it easier to access data, especially from these types of platforms that Ian just talked you through? Since those are the platforms that we want to be able to leverage to build the types of software experiences that we deliver to our customers. So those are a couple of the things, thank you, FaZe, that I'll be touching on in this talk, because essentially data really fits into that software experience that at the end of the day we wanted to deliver to our customers, to our employees, to our partners. Some of the talks this morning outlined, what are the different areas that we touch with digital transformation? And sometimes it's our customers, sometimes it's through marketing, but sometimes it's actually a lot of our own employees through the digitization of our internal processes. And when you think about connected things and some of the opportunities that we have with an increasing number of connected devices, a lot of the beneficiaries of that are actually going to be some of our internal workers who can now work much more smarter. That totally was not proper English grammar. I'm from California. We barely speak English. That helps. It's the Independent Republic of California. I'll show you my passport later. So in the context of that, a lot of folks have talked about big data over the years, and technically, one of the products that I oversee is our big data suite, which is really just a package together of a portfolio of software that's scale out databases. But this notion of big data has been around for a couple of years, and a lot of folks have kind of started down this path. But I think where some of the disconnect happens is that what ends up happening with the data that people are sticking in a data lake. Even if they're moving away from their traditional architecture, they're starting to set up, a Hadoop environment somewhere. But at the end of the day, who's consuming it? What is it powering? What types of experiences are being driven from all that data? And a lot of it is still the same sort of business intelligence tools. I kind of picked this goofy picture because she's sitting here with 3 different screens up with all these different bar charts, which is obviously like a staged photo, but it really kind of tells an important story. I've walked around the vendor halls at business intelligence and data conferences, and a lot of the other vendors there, it's just looking at prettier bar charts, more interactive bar charts. At the end of the day, it's still a bar chart. At the end of the day, it's something that a human has to sit there and interpret what's happening. And a lot of people don't really have the time or wherewithal to make sense of, the trend seems to be going this way. I guess I better make this decision. Not that there won't still be business analysts and business intelligence, that definitely always will have a role to play. But I guess the challenge here is to think about, okay, what we're doing with our data, how is that going to reach a broader audience? It's the sort of subset that is people who will consume tools like this is a tiny fraction of the number of users that we can reach when we start to put data into other experiences. So I'm going to pick on a couple of examples of some of these, very notable companies that have software as a core competency, and I think it's also interesting that they're operating across different industries. Uber is, of course, one that gets picked on a lot. I know was mentioned earlier today. So this is one where one of the sort of killer app features, I think, in Uber is this little number that pops up right here. So I know Uber's used here. I did have a briefing, by the way, in San Francisco with a Korean company, and I was halfway through this spiel, and then I paused and I realized, do you guys have Uber in Korea? And at the same time, one guy said yes, and another guy said it's illegal. And then they turned to each other, spoke really fast in Korean, and then turned back to face me, and one guy said both. And I was like, Glad we cleared that up. Okay, moving on. So you know what this experience is like. So as opposed to the olden days when to get a taxi or a ride, we would kind of go down to the street corner, kind of wave our arm like this perhaps, and like a horse and buggy would come. You know, we don't know if we're going to be there for 20 seconds or 20 minutes. And so, you know, we don't have the data and we don't have an experience that's going to provide us that. Maybe we call a dispatcher and you get usually kind of a grumpy person who gives you a really big range. You're like, well, it'll be there in, you know, 30 to 45 minutes. And, you know, they don't actually really know because like the taxi driver is going to make his own decision and sort of show up like at an hour or shows up in 15 minutes and you're like, oh my gosh, I was totally not ready for this. If you're like me. So anyways, this little number here tells me, okay, I've got time to, you know, pack up my bags, say bye to my colleagues, have one more drink, whatever it is. Or it's like, all right, I've got to just grab my stuff and go, Irish goodbye, and see you on the street corner. So this is a great example of the experience where it's all very data-driven, right? There's a lot of analytics that powered that type of experience, but it just surfaces in a very simple way in that application experience, and it changes what that user is going to be able to do. It catches them in that moment, and it lets them make a decision. It's not a bar chart, right? It's not, you know, I have to now do a mental regression analysis on the likelihood of the taxi arriving in 15 to 30 minutes. It's something that I can now make an in-the-moment decision based on. And then, of course, the other thing that I think is interesting, if you dig into some of what Uber's been doing with their data science team, is picking apart these data sources, taking things like, for example, you would think empty cars, riders, simple matching, right? You know, this is, and maybe we can use location proximity. Well, they took it a step further. They actually started to decouple those data systems, and then within the supply part, right, which is the cars and the drivers that are available, they started to then add a predictive element, which is to say, instead of saying, okay, here's a rider at the warehouse by Old Street, and the nearest empty car is 13 minutes away. Instead, it actually is able to say, well, there's actually a car that is 2 minutes from dropping off a passenger, and at that point, they will be only 2 minutes away from the warehouse. And given that we're not going to assume kind of a tuck and roll exit of the passenger 1 to passenger 2, let's add a minute or whatever it is there. And now we know that that car is 5 minutes away. Basic math, 5 minutes, less than 13 minutes. Let's put that car in front of that rider, right, waiting there at the warehouse. So now we're actually, with just that move and a little bit of a predictive element added, we're able to increase our measurement of supply, since this is a basic sort of supply and demand matching exercise. So that's kind of a fun one. The next thing that they did is they started to sort of, people drop pins or add addresses. They started to do a lot of predictive work around trying to figure out where are people really trying to get to, because sometimes people drop convenience locations, which is not really where they're going. And this is something that I don't even fully understand it, but they directly attribute their ability to start to more accurately predict where people are trying to get to, as opposed to the approximations, with their ability to introduce Uberpool. So, and I know Uberpool is available in London because they comment about like how much traffic they'll take off London streets, and they picked London, not New York, not San Francisco, they picked London. Apparently you guys have really bad traffic. So, if you recall, Uber started with a black car service, and so this was, the sort of high-end private vehicles. Then they moved into sort of your regular private vehicles, which is the UberX service. And so by adding Uberpool, I think of it as, you went from your first class, and then you had business class, and now you have like economy plus. Like you're not quite on the bus. You're in like, okay, you're gonna pay a little bit more than you would pay for the bus, not quite as much as you would for, the UberX, the business class service. But that's classic if you remember from your economics classes, which I'm sure everybody here took. That's classic price discrimination along the demand curve, which is the way to capture the most margin, right? And so what I like about this is their ability to change their business models quickly, introduce new services, is directly attributed to their ability to work very cleverly with data and start to add little predictive elements into what they're doing and the data that they have access to, which is a combination of location data, right? Everyone walking around with their mobile phone is carrying a sensor, a wonderful sensor, right? People are connected devices now because of this connected device in their pocket. And so that's what the drivers have on their dashboard. It's giving them information about where the driver is, where the rider is. Plus you have traffic data, weather data, what have you, that you can factor into your ability to calculate these types of predictive elements. So that's kind of my first example that I like to pick on. The next one is Netflix, which Ian already talked quite a bit about Netflix and some of the transformative ideas. So obviously we work with Netflix, we've worked with Uber before as well. So Netflix attributes over 75% of what people watch on their station, on their platform, to these reels, right? And if you think about this, they're introducing a new way of consuming media. In the olden days, right, you'd get in that horse and buggy, and you'd end up at Blockbuster. Remember them? Yeah, they're not there anymore. But Blockbuster was pretty easy because you could just stand there and kind of like scan the shelf and sort of probably go through the new releases. Maybe sort of if you're kind of getting bored of that, go into the section where they have everything lined up this way and you have to actually kind of read the sideways print. But when you start to open up the entire catalog of like human moving picture media history, you now have an overwhelming experience for anyone trying to consume that. And that happens all the time. If you think about, you try to put all the mutual funds and ETFs in front of your average investor, it's a little bit too much to consume, right? So there's a lot of different examples of where we're overwhelmed by choice in today's society. And anyone who's dealt with a toddler knows that you usually actually want to put like 2 or 3 things in front of someone, and it's going to be a lot easier. So these recommendation reels, which is anyone use Netflix familiar with those? That's what's driving their service, because this is essential, for one thing, to actually being able to use their service. Second of all, it's adding a bit of intelligence, right? It's saying, hey, we notice what you're watching and we're going to recommend some things that we think are going to be relevant to you. And they actually did some really famous data science challenges just with the public, where I think it was like $1 million if you can create a better algorithm for the recommendation reel. It took like 6 years before someone could break it. So that's the next example. The last example is not, as far as I know, we haven't done any specific work with Airbnb. Is everyone familiar with Airbnb? Okay, but personally, they're one of my favorites to talk about. My husband's a super host, which is an important status to achieve. And my mom was in hospitality, so I kind of grew up like going to high-end hotel chains and being completely spoiled from a travel perspective. But nonetheless, Airbnb, one of the things that's really important for their service to work is that they need to help their hosts, right? If the hosts aren't getting a good experience, they don't provide the supply. And that kind of, it's a similar supply and demand situation with Uber. And if they don't have the supply, then people kind of coming there to book their next travel accommodations, they're not going to have the selection or just, supply available to them to choose from. So one of the things that they noticed is one of the top questions that they had on their support forum was, how much do I charge? Makes total sense. They're dealing with people who are not Hilton and Marriott with decades of data in terms of, in this market, this time of year, this is what you charge, and obviously like plugged into the travel systems that allow them to have competitive pricing at their fingertips with people who their entire job is to set pricing. You're talking about people like my husband who just rents out like an extra cottage that we have. And he's got to make a decision in the moment. He doesn't want to look at the bar chart. He's a pretty clever guy, so he actually probably wouldn't mind looking at that. But most people, they just want help, right? And so what I like about this example is thinking along that customer journey. There's sort of the marketing end, which a lot of people have already sort of started to look at from a digital perspective. How do I get their attention? How do I bring them in? Then there's that experience part, right? Like, how am I actually using your product, which I think there's some great examples in here. But then there's the support end, which is actually where there can be a lot of costs associated with that. And so how can we use data to actually deliver a better support experience? I think is a really interesting question. So what I really like about this one is they took something that was a support question and they turn it into a feature in their software. So this just shows up on the side, right? When you're in their application setting up, hey, I've got an extra cottage to rent out. So it's right there, helps you make in the moment a better decision. It's powered by over 5 billion data points that went into an algorithm that they built just to power this. And so this is now something that not only preempts a support issue, it actually creates a differentiating feature, which now someone else would have to replicate. And once you move into, digital and software, you have to operate in that manner, right? When you're in capital-intensive industries, your barriers to entry are, do we own the land? Do we own the machinery? Do we own the factory? In software, there aren't those sort of capital-intensive. It's your features like this. So those are some of the examples, and if we just kind of push into this, now we can sort of strip away the familiar brands that we've sort of interacted with, and now just start to imagine, instead of the bar chart experience, imagine a lot of different other users who are now benefiting from just a little predictive element added into their day. And we can even go a step further in terms of, okay, we all know that your ride is 3 minutes away thanks to Uber, but now think about all the other different things that could be so much easier if we just knew that, that insurance adjuster that was gonna come by the house to look at the fender damage we got and that little bumper issue we had last week on the roadway. What if we knew more precisely when he was going to show up, he or she was going to show up at the house, so we weren't chained to our kitchen table for half of Saturday, which is really what you want to do, especially when you have small children at home, is I want to stay at home all day waiting for the cable guy, the refrigerator deliver person, or the insurance adjuster to come by. I can tell everyone's totally empathizing with that experience. So anyways, you're sitting at the doctor's appointment, right? How many times is the doctor running late? A lot of different places where just that little predictive element can now change the way I'm going to go about my day or my work day. So we can go a little step further and actually think now proactively using the push notification as the modern day tap on the shoulder and saying, okay, I'm going to preempt. Someone actually mentioned this morning in the plenary sessions. I'm going to preempt a customer service issue, and instead of wait for them to call me, right, which is an expensive interaction to have when they have to get on the phone with one of my call center agents, instead, I'm going to detect something is wrong, calculate who's going to be affected by this, of course, kick off the processes to resolve the issue, but at the same time, proactively reach out to the folks who might be affected, give them a heads up, give them a prediction in terms of when it should be resolved, and of course, maybe a low touch option for them to be able to get more information, so that now I'm not sort of creating this experience where they're going to have a bad experience first, then they're going to reach out through probably my most expensive channel to support them, have probably a bad experience because that's when everyone else is calling in, so now they're going to wait on the line. So they were already mad and they just got madder. And you might have a bunch of people who aren't affected yet that you're letting know that there's an issue, but they're getting a heads up, right? So they're aware of the fact that something is going on, but it's under control. Someone's working on it. It's just an idea. So I guess the question then is, how do we get to that point, right? I kind of mentioned earlier, we're sort of 10 years in on this Hadoop journey that a lot of people have been on in terms of, okay, we know we want to take advantage of a lot of data. Maybe we've started to set up a data lake. And so I run into, basically at this point, any customer or prospect or company that I end up talking to, you ask them if they have a Hadoop, and yes, but it could be sort of something with spider webs growing on it in the corner or somewhere in IT because no one's really figured out how to use it and actually gotten something out of it. Now there's a few great examples and exceptions, but where a lot of folks are is they've started to do this, and there's a number of challenges that sort of show up here in terms of, well, we wanted to build this big enterprise data lake, and we assumed everyone was going to show up and put their data in it, and then amazing magical things were going to happen from it. Somehow that's not happening. But what we want to get to is this over here, where we're using that data to make a prediction and create a different experience for our customers or our internal employees. So what's the gap there? One of the challenges is, of course, how are people accessing the data in this data lake? And have you now created a system that is its own separate silo? So one of the things that the patterns that we see in terms of these companies that are really transforming how they're working with data, and that's powering a lot of what's happening from a digital transformation perspective. There's sort of a number of micro trends within that. I just invented that word, micro trends, hashtag. One, open source innovation. So you heard from Dieter this morning from Volkswagen that they went from kind of being afraid of open source to embracing it. From a data perspective, there's been an explosion, a Cambrian explosion, if you like to use geology terms or paleontology terms. Cambrian explosion in the number of different databases, data management systems, because they're not all technically databases, that have become available over the last, say, 15 years. And almost all of them are coming out of open source. If you go back 20 years ago, the answer to pretty much everything was relational database, right? And so the relational database in and of itself, while there's still many, many important uses for it, is kind of monolithic. It's the Swiss Army knife that's going to try to do a lot of different things for you. And so it solved a lot of things in the early days of application development. But it in and of itself can be part of the problem. And in the meantime, you've had all these different, whether it's like a performance issue or a scalability issue. Now when you start to get more creative, this explosion of different data management systems, some of which might really focus on a narrow set of use cases, but might be really good at solving, very fast in-memory reads that need to happen. And its job isn't to solve all of these other things. And the same thing happening from, a query perspective or just from a scale-out analytics perspective. And so that's an important thing to be able to take advantage of all these different data management systems that are very useful. You kind of need to embrace open source because that's where all of these data management systems are being developed. So the next one is parallel processing. So one thing that the relational databases weren't, you had to scale up as opposed to scale out. And that's something that is a huge differentiator in terms of, when we're operating at web scale and massive scale, even though it's kind of doesn't make sense to always talk about everything as big data, there is an important element there in terms of the ability to scale out. And so this horizontal scalability then requires parallel processing across that. And so if you can't support that, you're going to introduce a bottleneck in the system. Cloud native continuous delivery, I don't need to elaborate on because I know Ian's already touched on it, but this essentially goes along with creating those experiences. You need to be able to continuously deliver, and the data needs to be able to support that. So some of the things that come up there that I think are interesting is, for example, when you're doing continuous delivery, and you want to do a blue-green deployment, which is basically the one version of the software, and then you're at the same time deploying the next version, but you haven't put all the users on the new version yet as you're sort of testing some things. What if you've changed the schema in the process? So this introduces some interesting concepts like a schema registry. And that really starts to drill into, wow, there's a very different data architecture that you need to embrace in order to be able to support some of those changes. Things like loosely coupled microservices, which would go hand in hand, in my opinion, with embracing all those different open source data management systems. So when you start to decouple the application, now there isn't so much of a requirement to use the Swiss Army knife relational database. We can, if we have a loosely coupled service with bounded context, it's going to have its own data management requirements. We can optimize what data management system we use for that service based on that service's requirements. If it's speed high-speed readability, then let's put something in there that's in memory and highly performant on reads. If it's something that's high-performance writes, let's do something in memory that can support, consistency and transactional abilities, and so on and so on. And so that's something that you can now, by loosely coupling those services, as well as all the different steps along the data pipeline where, these monolithic, ETL processes, which make it very hard if we want to introduce a new data source into the flow of data we have into our organization. Having to go back and thread that through an application that's monolithic is very challenging. So if we can start to loosely couple, hey, we want to ingest data from these sources, we want to process data in these ways, and then we want to be able to land data in different sources. We have certain elements that are online supporting the real-time element, but we have certain processes that are offline because there we can start to play around with data at massive historical scale. We're not going to do all of that in real time. So we're gonna decouple the way that we work with our data. And then lastly, data science and machine learning, which is, is everyone here familiar with machine learning? So we want to be able to continuously learn and build better algorithms, build lots of algorithms. I used to make a pottery analogy here, and I think most people were just like, why is this woman talking about pottery? But I swear it all made sense in my head. Instead, it's, instead of trying to, okay, we're gonna hire some data scientists, stick them in the corner, and they're gonna work on the one true algorithm. Think about, we gotta build lots of algorithms across lots of different applications. If you look at all those little predictive elements that are going into, let's just try to find an algorithm and build something that's gonna just help predict when the drivers are done dropping off and when they're gonna be available, right, in the Uber example. And then at the same time, we wanna do a separate round of prediction around where do people actually wanna go. So you can see there's not just one algorithm, there's lots of them, and they each need to iterate separately. And the data that's going to be training those algorithms, we need to have a way to constantly retrain those against new data that's coming in. And then we need to have some way to actually put those live into the real-time flow of the application. So these are some of the problems and approaches that companies that are really good at data have embraced over the last few years. Now, the challenge, of course, is that most organizations are looking at something more like this when they're kind of like holding a stiff drink in their hand and in the mirror saying, am I honestly doing big data? So am I really data driven? Like, yes, we have some Hadoop, and yes, we're doing a few things, but now you're on your fourth drink and the lines are getting blurrier. But there's a lot of proprietary systems that are very difficult and expensive to scale. There's a lot of very rigid ETL processes and data flows, often that are flowing in one direction, taking the data out of an application, marching it through a number of processes and landing it into the analytics. How does the output of the analytics actually find its way back into the application? That is something that is challenging, right? And so all the arrows are flowing in one direction, and there's no arrows flowing back to plug something in an automated fashion. Now, how does this affect the application? How do we have, in real time, a new algorithm that's being used in order for XYZ prediction? And so a lot of batch-oriented in that marching through the processes. Those steps that we're marching through are slow and happen overnight. So it's very difficult to actually have any kind of real-time update going on in terms of the application experience itself. So sometimes what happens is we put a data lake in, and okay, so the data lake is there, maybe that's gonna fix everything. We've already kind of touched on the fact that you can't just magically solve and erase everything that's underneath it, which is why this ends up being just one more pile. And we might even add in some other elements. We might add agile developers. We might add some data scientists. We hired some data scientists. We're not really sure what they're working on. But there's still some things that are disconnected. And so, the data pipelines haven't really been addressed. The continuous delivery of data services hasn't really been addressed. And so for some reason, the speedboat on a big, beautiful lake that we thought we were building is like still sitting there. And the engine is just like revving, but we're not really going anywhere. So this is usually kind of a disappointing part of the story. And you kind of have to ask yourself, like, wow, did we make any progress by setting up that data lake? Now I'm really frustrated, and I don't want to spend any more money on big data exercises because I sort of feel like this is where we are. Okay, time out, pause. Let's think about what's actually required when we go back and think about the outcome. So Robbie had some really good comments in his session a couple minutes ago about, hey, so let's, instead of the metrics, instead of thinking about the program that we're running, which is program, operation data lake, we're going to build it, and then we're going to have a data lake. Instead of looking at it that way, it's thinking about what's the outcome we're trying to achieve. If we've got that user and we want to be able to tell them proactively, a very simple thing like your insurance adjuster will be arriving on this day in this narrow window of time, as opposed to a 4-hour window that you are now waiting around. Let's unpack what goes into that and start solving for those things. So we know that there's going to be huge volumes of data, right? And this is usually where a data lake comes in handy. But I've got a few recommendations at the end in terms of how to think about what data goes into that first. So we've got huge volumes, and we know that we're going to want to do some parallel processing analytics on top of it. Otherwise, you've just got another bottleneck there. We know we're going to be building lots of analytical models. We know that's going to require some data science work. We know that we need to be able to plug the models. Models are just, it's an algorithm, it's math, it's a table, the output of which is usually a confidence rating against something that's going to happen. So there's an 83.2% chance that the car will arrive in 36.2 minutes. By the way, that's not usually the user experience you want to deliver, but that's what the algorithm is technically telling you. So we want to wrap that in the API that the application can now consume as one of many services. And so this kind of goes back to this whole part of the application is iterating on its own cadence, right? Another part of the application should be able to go at its own velocity. So some of the elements that Ian touched on in his session about why decoupling is so important. We know we're going to want to adapt that data pipeline. So we don't want to say, just like in kind of the fallacies of waterfall methodology where, hey, we're going to prescribe exactly what we need from this application at the beginning, and then someone's going to go build it, and we're going to get at the end of it what we needed. Well, what we always find is that, however many months later when it actually shows up, requirements have changed. Same thing with the data we're going to use. Let's not assume that we know all the data sources that are going to be required for whatever algorithm, whatever feature, whatever prediction element that we want to introduce into our application. Let's not assume that we know all of those things up front. Those things might change. New data sources may become available. How do we then make sure that we can plug those into our data pipelines so that we can use those too and not be hampered and hamstrung by the fact that changing a data flow in a data pipeline is extremely painful. And then lastly is we want to be able to notify the application that something new is available. So this is where introducing the idea of an event-driven architecture is really important. And especially when you move to a decoupled application architecture, event-driven is very useful because now you have a lot of different services that are kind of operating on their own cadence. And so this is a helpful way to make sure that everything can try to keep everything in sync, but that you notify the right events to the right services. So I'll go through quickly the last couple of slides I have in terms of what Pivotal's sort of working on in this regard is a couple of different areas. First is our portfolio of data software, which is, they're all based on scale out, supporting kind of the scale out analytics for machine learning and data science, scale out in-memory processing for event-driven architectures, those types of things. We work with a number of different partners as well. Because one thing that happens in this Cambrian explosion of data management systems is that it's very difficult to have a silver bullet when it comes to data architectures. So it tends to require embracing kind of a multi-vendor and multi-platform approach. Second is we actually have our data engineers and data scientists that work with our customers through a lot of these changes and transformations in their data architectures, as well as kind of building some of those algorithms and sort of in that same Pivotal Labs teach as we build together way. And then finally, in terms of providing access to that data on the platform, we're working on a number of different data services on Cloud Foundry, and many of those also come from our partners. Because as I mentioned here, it's this notion of polyglot persistence, where we want to make sure that developers have access to a lot of different types of data management systems, because there's no silver bullet. It's not going to be your answer to everything is relational database. Just tell me your question and the answer is already relational database. So how do we enable developers having a wide variety of data management systems that they can easily work with as they're building applications, and then support how they run in production? So quick example of a customer that's kind of working through this architecture, and this is, I'll go through quickly because it's sort of the big technical diagram that sometimes is overwhelming. So they've got a customer application and they want to add a new feature to it. So they already have the application. Well, there's transaction data coming in from this application. We want to be able to ingest that data, process it against different things, filter it, enrich it. There's a whole set of verbs that you can use to describe what happens in the process stage. And then we need to sync it. Well, obviously the application is still running, so one of the places we need to put that is back into the application, something that's supporting the transactions and supporting that event-driven architecture. But at the same time, we're going to be landing that data somewhere where we can start to do the historical analysis across lots of different data. So there's the online component and there's the offline component. And here, instead of just supporting kind of our traditional reporting, we want to be able to make sure that we're enabling all of our legacy tools as well as our sort of new data science practice to be able to make use of the data that's landing in this data lake. So in this example, I have HDFS because this is kind of based on an actual customer model. So I'm picking the technologies that they used. And so here are some of the parts of our portfolio with the little icons to illustrate where they fit in. But as you sort of see, kind of moving up the stack from we land the data, we prepare the data in some way so that it can be actually used by these tools, right? And then we want to be able to actually do the modeling work. And so here's where we want to be able to make use of a library of algorithms that's actually designed to run in parallel. So the parallelization question comes back. And the output of which, PMML file is a very common format. There are probably new ones that are going to become available and improvements to that. But nonetheless, we need to be able to plug that in so that now data coming through this pipeline is getting scored against the latest model. And so this is kind of the circle connection back, as opposed to the data arrows always flowing in the same direction. And so this is just a kind of a high level example. If we look at how this customer kind of goes through this journey, they had a lot of data silos and analytics silos, as many companies do. And they want to be able to make use of data sources that they hadn't even tapped into yet. They know they have the account data, the transaction data, but then there's all the web interaction data. How can they make use of that in being able to provide some kind of prediction? So they started with this analytics road mapping. And this is where we want to make use of understanding there's a lot of different ideas of what we could do with data, but how are we going to decide what we're going to do first? How are we going to prioritize that? That requires bringing in stakeholders from different parts of the organization. So it can't just be IT, it can't just be the business analysts. You need to have lines of business in there as well, making that decision all together so that it can be supported as it gets implemented. So this was how this customer came through. Okay, we want to build something that's the next best offer, but in terms of understanding that roadmap, it required on first being able to predict the next likely purchase. So they actually identified, here's two algorithms we need to build. One is going to support the next one, but this helps us now kind of build that roadmap of how we're going to, crawl, walk, and then run. So after that, they actually worked with us on a data science engagement to build that first algorithm. What is the next likely purchase that this customer is going to make, which we need to know before we can now predict and optimize an offer for them. And then finally, there's sort of the implications to the data architecture to support that specific use case, and making sure that we can bring in these new data sets, which might introduce some different requirements in terms of, okay, this is going to be, when you start to bring in clickstream data, what everyone is doing on the websites, that's going to be a pretty high volume data set that we want to be able to make use of alongside our account data and transaction data and the offer data that we know we want to use to to optimize that offer. Okay, so then how are we going to take advantage of that in a parallelized architecture? So just another quick example that I want to point out, that was an example where they have the application and what they're trying to do from kind of the digital transformation perspective is add that smart feature. Well, sometimes what needs to happen is actually the application itself hasn't been built. And then there can be their own, like a different set of data requirements for that. So here's just Ford as a company that we've obviously been working with a lot, and they introduced their Ford Pass app, and here one of the things they've got is just the user data for that application. They're building this in a completely cloud-native way, and now we just need to help solve some data challenges in that cloud-native way. And so provide active sync of user data across different clouds. So this is a different type of data challenge that didn't necessarily exist before. Okay, so here's my kind of sum up recommendations, which is start by focusing on the user and the app. So I help with a lot of different briefings in San Francisco. A lot of folks say, hey, we've got this data set and we want to monetize this data set. And so my challenge to them is think about what's the user whose behavior you're trying to change. And let's work back from there. As opposed to, I've got this awesome data set, I know that there's like gold somewhere in here, just help me find it. So whose behavior are you trying to change, right? Is there already an application in front of them? Great, let's figure out how we can start to infuse some data in there, that little circle with the number in it, or just that little tidbit of insight as opposed to plugging in a whole bar chart. But let's start there. Oh, okay, you don't have an application in front of that user, or the one that you do is not really supporting what you're trying to get to. Let's figure out how we build that, and in the process also build into it some kind of data feature. So, oh gosh, did that not build? Okay, sorry, that was the first one. So the next one is identify the data sources. So this is kind of where folks had you guys know the movie Field of Dreams? It's kind of an American thing because it's all about baseball, but Kevin Costner movie from like 1989, and there's this famous thing where it's like, if you build it, they will come. It's a guy who's having crazy voices in his head and decided to build a baseball field in the middle of Iowa. Totally doesn't make any sense. But the if you build it, they will come mentality seems to be a big part of what happens with data lakes. And if we build this data lake, all the other parts of the organization are going to show up, with their vials of data or something and pour it into it, and it's going to be a wonderful ceremony where we're all sharing data. And in reality, this department doesn't really trust that department, or this department kind of thinks their data is super special. And so this data lake that's enterprise-wide doesn't really exist. It's kind of this mythical thing. And so as part of the process, whoever's building that app that's in front of that particular user that you're trying to assist and facilitate something, now work back to what data do we have access to? And that's going to be a lot more useful way to start. And some of that data might be external data, some of it might be internal data. But if we work back from there and we start to prove out great things with this new feature we're building, lo and behold, other parts of the organization will show up. So example here, IT built a data lake to look at all the monitoring data that they have for servers and app level details. And there was a big outage of an app, and line of business says, you know what, it's the availability of the app that's affecting the performance of these workers. Well, they started to go through the reports that were being built and actually discovered that that's not the case. So now that business unit is starting to provide more of their data into the data lake because they're very curious to understand better what is causing our workers to not be as productive. So that's kind of this pattern that we see. And then finally, once you've kind of worked through those, then you start to build that roadmap and knowing that, we know the ultimate destination we want to get to, but we're going to have to build algorithm 1 before we build algorithm 2. So that's kind of the exercise that other customer journey we walked through touched on. So hopefully that was helpful. And I know I went a little bit over time. I blame my boss who went before me and went over. So anyways, I'm around if you have any questions, and I'm at Dormain Drewitz if you want to harass me on Twitter. Apparently that's what we invite people to do now. And so thank you.